Hi everyone, welcome back to the channel. I hope you're doing great. Uh, Today we will discuss or we'll learn about data pre-processing techniques. And in the previous couple of lectures, we learned about the roadmap of NLP, natural language processing. Then we learned about the standard pipeline, which is what are the standard pipeline, are the processes in which we need to go through in order to create a natural language processing model. So we learned about that, and in the next lecture we also learned about data cleaning. What are the different steps to clean the data? And we have also cleaned our data, which is here you can see. So this is our text file. We have cleaned this. Our original data was something like this. We cleaned it and made it like this. Okay, if you haven't watched those videos, I would recommend you to go through those videos and then watch this one. So here I've prepared data preprocessing techniques tutorial notebook. Here I have pinned down some of the techniques like tokenization, stopword removal, stemming and lemmatization, and then POS tagging and name entity recognition. Okay, so these are some of the most important and most used um, data preprocessing techniques. So we will learn about all of them one by one. Okay. So, what is actually data pre-processing? It is one of the crucial steps in data analysis, and as I mentioned, machine learning pipeline, and it involves transforming raw data, which we just saw the raw data we have here, and into clean and usable format. So we divided the pre-processing technique into two parts basically. One is cleaning and then one is pre-processing. These are two separate. You can also use them as one, or you can name as one. They're the same thing. So then this in this tutorial it covers common data processing techniques including tokenization, stopword removal, stemming and lemmatization, and removing digits or punctuation. We did it in the previous lecture, removing digits and punctuation. So we won't cover that here. And then POS tagging, also NER or name entity recognition. Okay, so these are the some of the main techniques we will learn about today. First off, let's learn about tokenization. What is tokenization? It's basically the process of splitting the text into individual words or tokens. Like, let's say you have a huge file. Okay, now you're dividing that file into one by one words or into small sentences. So that's what we call as tokens. Token is just a small piece of some text or whatever. You can call it just a word, dividing a whole file or text file you have into words. That's we can call as tokens. So here we will do the tokenization part. Okay, so first off, we need to install analytical library. That's very important. Natural language toolkit. Uh, then the next thing is after installing, we also need to import that uh, so that we can use it and open the file here. Open that text file. Okay, so let's open that. What I'm doing, file, and for that just open, and our file name is cleaned data.txt. So we would open that, and then it is also given us suggestions. So let's tab this. Yeah, it's okay. I think we don't need this part, so this is okay. So here let's name it the data. It's fine. So after opening the file, you can also print it here to check whether it has opened the file or not. Here you can see our is has been opened here. Okay, Now the next thing is we need to tokenize the file which we just read here. Okay, we need to tokenize the files. For that, just it's a simple the step uh, NLTK dot word tokenize. It's also suggesting just tokenize the data. And one more thing, I think we also need to specify the language here as well. It is English, and we also need to specify that preserve line should be not false, but it should be true, so that it also preserves the lines of our text. Okay. All right, so that's fine, and then we need to print the tokens. Okay, so now it will divide our whole text into small tokens. Okay, let's run it. Here you can see it is giving us list of tokens where all these have been changed into this is an example of unclean text and so on so on so forth. Okay, now we have successfully divided the file into tokens. The next step is stopword removal. Stopword removal, in short, it is just removing the unnecessary part of our text. Like this is here you can see this is unnecessary, and unnecessary, which doesn't add any meaning, a significant meaning to the text. Okay, to the whole concept of the whatever in the text. So therefore we need to remove all those in order to make it easy for our model to train on. Okay, so first thing is you need to import corpus from. Okay, so you need to first import the stop words. Stop words are these words, like this is and all these are what we call stop word. We need to remove these words from the text which we have. Okay, so for that, um, just first import the stop words, then it's recommended by someone, that's great. Then choose the set of stop words so that it could not include any duplicate values, and then among the tokens just tag the one which are not in step word, and yeah, then print the tokens. That is also okay. Okay, now that let's run it. Oh, here you can see all these top words have been removed. For example, this here we had this is and all these things are removed. Now we have just example unclean text, contain typos, grammatical error, extraneous character, NLP, and all that. Now the next part is stemming or lemmatization, where we just normalize the text which is used in NLP, and so that we could reduce words to their base or root forms. And if you talk about stemming, it involves cutting off prefixes or suffixes of words to obtain their root or base form known as stem. The purpose is to treat word with similar meanings as if they were same. Stemming is rule-based method that does not always result in a valid words, but is computationally less intensive. And then we have lemmatization, which is unlike stemming, it involves reducing words to their base or dictionary form, known as lemmas. It takes into account the context of word in a sentence and applies morphological analysis. Lemmatization results in invalid words and is more linguistically informed compared to stemming. So what we just in this part is, let me just give you an example. Uh, in a markdown, let's say we have three words: eat, uh, eating, and eaten. Okay, so these are three words we have. Now in case of stemming, what we would do is we would just write eat, and we would write eat here, and then we would just attach all the other parts like ing, en with it. Or you can also take an example of universe, universities, and university. Okay. Now we could just, in case of stemming, we just reduce into universe. Okay, and then add the se cities and city to that. Like universe could be the stem or base form, and then we could add cities, city to it, just like that. So that's what we call as stemming. Now here you could see that universe is not any, any right word in English. We need to use something which is actually have meaning in English. So for that we use lemmatization. It's just upgraded form of stemming, where instead of just chopping any word to this its base form, we search in the corpus of words we have in English, and then and use that lemma for our purpose. So we learn about these here. We have stemming, and now here we need to import something like from NLTK, oh sorry, that is stem. We need to import ported stammer, which is also good, and we also import word lematizer for lemmatization. These are the two uh, main libraries we need to import, and then we need to initialize them. For example, a stemmer, or just stem would be ported stammer, and for lemma we would use, let's name it lemma. We need to use wordnet lemmatizer, and now we need to, for stemming purpose, we would just stem the words in the tokens we have here. From these token we'll stem, and for lemmatization we could I think we need to name it stem words so that we could print it separately, and here lemma words, which is equals to, here we have lemma dot lemmatize words in tokens. That's pretty much it. Then let's print stem words, let's print lemma words, and that's it. Let's run this. Alright, here we have for stemming, we have stem words example just like this. Unclean text contains typo and grammatics extrain, and yeah. Now here you can see the difference in lemma words. We have example hasn't been changed into anything. Then unclean is okay, text is okay, content is okay, typo is okay, grammatical has been corrected from grammatic to grammatical, error has been, it's okay, extrain has been corrected from just extrain to extraneous, and character is just transformed into characters, NLP, and interest is transformed into interesting, and so on. So that's the difference between lemmatization and stemming. Okay, now the next thing is POS tagging. It's again a very important technique for data pre-processing, where uh, POS just stands for part of speech tagging, where the goal is to assign a grammatical category such as noun, adjective, verbs, etc. to each word. Like we are just defining or teaching a word, a grammatical category to each word, noun, adjective, whatever. So that's what stemming means. We just specify the part of speech of the word. For example, what does unclean convey? Is it a verb, it's adjective, or whatever? What is the part of speech of text? Is it a noun, or it is a verb, or it's an adjective? It's as simple as that. So posting is not that difficult. First download nltk download tagger, not just tagger but the English version of the tagger, and then just post tags, is equals to, yeah, it's right. And print post text is already suggesting that's great. So let's run this again. Here you can see example is what is JJ? I don't know what's the meaning of JJ, but oh, I think it's adjective. It's used for adjective, but it is not adjective. Example is not adjective. There's some error here. Then we have unclean, which is adjective. Text is a noun. Contents is a verbs. The typo is again adjective. Grammatical is adjective. Error is a plural noun. Extraneous is again adjective. And yeah, so that's what POS tagging means. All right, lastly we have name entity recognition, where we identify and classify name entities like person, name, organization, location in the text. For example, in our text, if we have, if you go here, uh, do we have any name here? Yeah, Jake. Jake means the name, and location is in New York. So we will try to find these in our text. Okay, so that's what NER means. NER is also very simple. Download max chunker. We need to download words, and then we could. Oh, it's doing by itself always. That's great. And post text, then print any. Yeah, I think we need to install tape, not just max int chunker, and just import the chunk, or we could just remove this as well and just write NLTK here for simplicity, and post tags. Yeah, that's pretty much it. And let's run this. Okay, here you can see, right, we got the output. So here's our output. So yeah, that's all for this lecture. Hope you got the idea. We discussed name entity, we discussed post tagging, stem and lemmatization, stopword removal, and tokenization. One of the important steps in text preprocessing. Okay, so that's all for this lecture. I hope you got the idea of pre-processing, and you learned something out of it. And if you find this video useful, do subscribe to the channel. Also share in your network. It helps really to keep going when someone's like you do, and or subscribe to the channel. That helps a lot. So I would request again you to subscribe to the channel. That's all. See you in the next one. Till then, keep learning and keep improving. Thank you.